Okay, we are now recording, so I can't deny anything anymore. Okay, let me just really, I didn't make a separate video going over the assignments. I just didn't have time yesterday. So let me just really quick, it's only one page long, just explain the assignment. Hopefully it's pretty self-explanatory. This week, 914, 918, we're doing sections 2.3 and 2.4. The 2.3 practice problems are 7, 9. They got a lot of parts, and 11 to 21 odd. And 2.4 practice problems are 7 to 23 odd. And again, these individually, they're not for a grade, but we will have quiz 4 based on these on Friday. And again, due Sunday. I'm trying to keep the same system week after week. And that will be a true false. The problem is correct kind of quiz. For WebAssign this week, again, go to the personal study plan, practice quiz for section 2.3. There's some stuff there that I don't want to get into right now, so I've only picked out parts 1A and B, 2A, just 3A and B, 4A and B only. And in 2.4, 1AB, 2AB, 3AB, 4AB only. And just email me the percent of these problems you get correct. We won't have a Google form for it. It seems a little too confusing about a Google form to tell me what you get correct. Just send me an email and I'll write down what percent of the grade or percent of these problems you get correct. Get them all, it's 100%. I wanted really quick to, I only emailed out a little short explanation about grade report, so I just wanted to go over really quick. I printed it out and using the camera so we don't have to switch back and forth. But I've tried in columns to show every column of our test grade. And so any column or any grade we haven't done yet, it has a 70 on it just as a placeholder, basically assuming you pass it. So the proctored test grade, if you can, sorry, it's jumping around and blurry. But the proctored test grade column right now has a 70. Your actual test grade should be on the non-proctored test grades. There'll be a list of those. 3 of those will be there. The syllabus quiz is by itself. It's up here, what I have for your syllabus quiz. And then quiz 1, quiz 2, these are numbered over here. Quiz 1, quiz 2, etc. down. So your WebAssign grade's the same thing. 1, 2, 3. And we haven't taken the final, so it's a 70. Here's the percentage that each grade counts. You have your averages here below each column. There's the equation to figure your grade if you can do it. I give you 3 lines to tell you what you need to make an A, B, or C. This person is not doing very well. I just punched in random numbers. They would need a 369 to get an A, a 269 to get a B, and a 169 to get a C. So with these grades currently, this person would not get an A, B, or C. And then right now, your final grade at the moment, again, with these 2 assumptions of 70, you can take to be that number. Your letter grade will stay blank until the very end after you've taken the final. I'll send you a report like this with your letter grade filled in. I hope that helps. Check for zeros if you think there's a 0 on there that's unjust. And by all means, let me know, hey, I think I turned that in, let me know and I'll investigate. And that's why I publish these reports, so everybody knows, what I think you have, and you can email me and yell at me if you think it's incorrect. I hope that helped. Is there any thing from the problems that you want to ask about? Previously from 2122 before we charge into this week's?
I don't have any questions as of right now.
Okay. Do you want to charge into some examples of 2-3 then?
Yeah.
Okay. Well, they're basically getting information from a graph. the easiest thing to do is probably charge right in to the first problem, and you can see the kind of things they're going to ask you for. So the very first problem, first homework problem, page 215, problem 7. You're given this graph. Take a second to draw it. I'll show you it from the book. It's read it there. Okay, it's number 7. It's this graph right here. Take me just a second to sketch it out. I can try to point to it. Got a dot at -3, 3. It crosses the y-axis at 0, -1. Just a little left of the 1 there. It's crossing just a little right of thing, and it has a dot at 4 and 3. And it's going through, looks like it's going through 2 and 3. Yeah, it's going through 2 and 3 because it's curling up and down. And it looks like that point is at 3 and 4. All right, that's about the best sketch I can make of it. And if you want to know what they want to ask, part A, they ask you for 4 y values. Part A, find. Maybe I'll draw them vertically. H of -2. They are calling this H. Actually, they're calling this y, labeling that the y, this, and they're calling this H. All right. First couple of things here are pretty simple. They get down to the inequalities in part D and E. You understand they're basically saying this is X. So they're basically saying go to X is -2, and they have the Y, bad graph, but basically on the graph there, it should be doing more of this. Reading the graph, at X is -2, Y is 1. Questions about that? I can show you the bad drawing, but basically at X is -2, your Y is up 1, you're crossing 1, +1. Any questions about that?
No, sir.
No? Okay. So then there's H of 0, and that means your X is 0. So do I go to X is 0, and I'm down 1. So that's going to be -1. Maybe to save paper, I'll go over here for the other 2. H of 2, so that means your X is 2. If I go over to 2, I'm up to 3. Basically, you find your X, and you go to where the curve is, because this passes a vertical line test. There's only one place to go. And you read the Y value for whatever that X is. So let's see, this dot is out at 4. Yeah, it's at 4. That's at 4. They wanted H of 3. So at X is 3, I'm up at this peak, and my Y value is 4. Questions about that?
No, sir.
No? Okay. All right, domain and range. Domain. Hope we got it across last section. That means X min, X max. And because they close these circles on the end, this is not going from -infinity to infinity. So that closed circle on the left, your minimum X is at -3. Your maximum X is at 4. And I froze. There we are. And there's closed circles at each end, so that's a bracket. If they had wanted it busted up, they would have made me some open circles. Any open circle along in here would have said, don't use this X. And I'd have had to bust it up with -3 up to that X and then 3 on. But there's no open circles given, so we're using any X between -3 and 4, including -3 and 4. Range, Y min, Y max. Thinking vertically, here you're going horizontally. It looks like the lowest Y is at -1. Highest is at up here at this peak is at 4, and we're covering every Y in between. So, and again, no open circles in the middle. So that's our range of Y values. Any questions about that?
No, sir.
Okay, part C starts a little trickier. Find values of X for which h of X equals 3. When you see an h of X like this, you can always think Y. I think we mentioned a Y equals a number is always horizontal. H of X equals 3, which means Y equals 3. Well, you're crossing in 3 spots. Here, here, and here. You want those X values. So the X value over here would be -3. The X value here looks like it'd be 2. And the X value on the very end of the curve would be 4. There'll be 3 values of X there for which the h of X equals 3. Questions about that? Is that absolutely obvious, or is that like whoosh?
I think it's really obvious.
Really obvious.
Yeah.
Okay, because in part D, they change it to less than. They stick a less than in here. So I hope you can realize how this is going to change. You're still going to have the or equal to, and these numbers are going to come in, but they stick a less than on it. Let me try to keep that visible. See D, find values of X for which h of X less than or equal to 3. Now that less than is going to be below 3. Your Y's, remember this is Y, are below 3. So if you look at your line, there's exactly 3. You want your X's below 3. Draw it up here. H of X less than or equal to 3. I probably should have made this a solid line because it was equals. Remember, there was a little convention. If you were equal, you were solid. Okay. Well, I'm going to be below. See, my answers now are intervals. Point this out. Answers are intervals. So I'm clearly starting at -3, which is what you got when you were directly equal. I'm below until I get over to 2. So the answers are between -3 and 2, but actually between them. But you see, between 2 and 4, I go, but greater than 3. That won't be in. So my actual answers are between -3 and +2, bracket. Not between 2 and 4. I don't know if, keep it on this page or go to the other page. Questions about that?
No, sir.
Okay. E asks about net change, and they did mention this earlier, but I didn't cover it. So, and they do, we're going to actually cover it in 2.4. Okay. Net change, turns out, I can show you the formula back. They write this way. Draw a picture of it. Take a line, and here's A and the Y is a B, and we'll, I'm sorry, we use this A. I'm screwing this all up. You want parentheses around that. Oh boy, not having a good day today. Let me try one more time. Okay, A, put a B over here. The Y value is F of A. The Y value here is F of B. Okay, are you familiar with slope?
Yes, y equals mx plus b.
Now that is the equation of a line. I'll write it down since you mentioned it. Y equals mx plus b is the equation of a line. But part of that equation is a slope. Do you remember the m is the slope? That ring a bell? This look familiar?
Y over x2 minus y1, yeah.
X2 minus x1. Okay, they're using this as x1 and this is y1. This is x2. Y2, and this is x2. Okay. In effect, this top is your net change. It's the top part of the slope formula. In the book, you'll see it with A's and B's. You can also, the net change is just y2 minus y1. I should just stick to familiar letters instead of using the stupid book A's and B's. Okay, so when they want RD net change from x equals -3 to x equals 3, I've got to find the y value at x equals -3. That would be 3. This means y equals 3 from the graph. X equals 3, it was 4. Y equals 4. So it's literally just a matter of going 4 minus 3, which is 1. You can see this from the graph. It's tough to redraw the whole graph here. But
So
basically,
y would be your net change?
the net, basically the net, they want a net change from -3 to 3. Right here. You can see it's 1. See at -3, you're at 3. At +3, you're up 4. So vertically, you've only changed 1. That's the net change. All you really have to remember is that it's the top part of your familiar slope formula. Maybe I can do another example. I don't know if they ask about it. They ask about it in the next section. See, in this section, I don't want to get into increasing and decreasing and maxes and mins. So I really asked for 7, 9. I've got the assignment here. I asked for 7, 9 will be similar. And 11 to 21, which is down here about finding domains. Sketch a graph, find domains and ranges. Do you want another example of net change?
I think I understand.
Okay. Just to point ahead, see here's 2,4, average rate of change. 2,4, they ask about average rate of change. Average rate of change is nothing but a fancy phrase for slope. See in the problems, just a second, let me bug. Okay, I'm back, sorry. Okay, let's see, yeah, in the homework. 5. Okay, yeah, see in 2.4 here, page 224, they're asking about net change and average rate of change. Average rate of change is your full slope formula. Net change is just the top. And I froze. Okay, we're back. You want another example of those while we're on it, or would you rather stick to 2.3?
I'd rather just stick to 2-3 for right now.
Okay. You want an example of something like problem 11, domain and range from a graph?
I actually think, yeah, if you don't mind.
Okay, let's contrast 11 and 13. We'll contrast 11 and 13 because it just depends on what information they're giving you. So this is page 215. Problem 11. 2x plus 3. A, they want a graph. B, they want domain and range. Okay, we've graphed before. Y equals, you're off, quit. Okay, y equals 2x plus 3. Clear that off. I use the standard window. All right, get a straight line with a y-intercept of 3 because it is following your mx plus b. One, two, three. Straight line. Right. Only a formula like this with no other information about it. You've got to give the calculator numbers. So negative 10, 10, 1, negative 10, 10, 1 are good as numbers as any. But you understand when they go for domain, these things go forever. Your domain would look like negative infinity to infinity. This is x min, x max. On the range, it's going to look identical, negative infinity to infinity, because this goes down and goes up forever, but it's y min, y max, even though they actually look identical. Questions about that?
No, sir.
Okay. In effect, we talked about problems. problems are square roots and fractions, and you don't have any square roots here or any fractions, you got no problems. No problems, formulas with no problems have this domain. Now contrast it with 13, because now they tell you f of x is x minus 2, but negative 2 is less than or equal to x less than or equal to 5. So now they want this formula between those two x numbers. They're giving you x min and x max. So I'll draw the graph here in a minute, but in part B, its domain couldn't be simpler. Negative 2, 5. And again with brackets because you've got or equal to's. Questions about that?
Nope.
They're just flat out giving you the domain. All right, I'll give you a quick graph, part A. X minus 2. Okay, but now I'm going to go to the window. You don't technically have to do this, but I will because they gave it to us. So I'm going to make that negative 2, and I'll make the x max 5. They don't tell me what to use for y's, so I'll leave them alone. Graph. Okay, so I'm getting a y-intercept of negative 2. I don't know if I held that maybe too shaky, making you all seasick. Y-intercept of negative 2 has got a positive slope. Something like this. Now, you got to be careful about, okay, because they gave me this, the line isn't going forever in each direction. So to find range, I got to plug in y for y min, I got to plug in x equals negative 2. So my y is going to be x minus 2, which is going to be negative 2 minus 2, which will be negative 4. I don't know why I put the p over there. Okay, so y max, I'm going to plug in x equals 5. So y equals 5 minus 2, which is 3. And my range will run from negative 4 up to 3, again with brackets because we had or equal to's. You can almost see that from the graph. Negative 4 on the y is down here, and it's running up to positive 3. So that's vertically what it's running. Questions about that? Not hearing anything. Was there any questions about that?
No, I didn't have any questions.
Okay. Looking at 17 is super easy. It's got no problems. You don't really even need to do a graph. Well, actually you do to do a range. You don't need a graph to do a domain if you remember the rules about problems. You do need a graph to get the range. Now 17's got no problems. 19's got the square root problem. 21's also got a square root, but it's going to be a lot harder and trickier because you got a quadratic underneath. You want to see examples of those?
If you want to, but I know you also have like a certain time to do your Zoom meetings.
What's it, 12? I got 12:30, something's opened up on that dumb clock. Well, I got 12:35. I got all the, I got time. But I don't want to hold you up if you got other things to do.
Could you just work out number 21?
Sure. Start on the top of a clean sheet of paper. Well, actually, it says work out domain and range from the graph. Well, let's see, 21 here. We're working out b. F of x square root of 16 minus x squared. All right, if you wanted the graph, find domain and range. From the graph, it wouldn't be hard. The algebra would be a little bit, you got to solve an equation out of last section. Part A, quick graph. Oops, okay, square root 16 minus x squared. Close. I'll go back to negative 10, 10. If you want a really quick way to get to that negative 10, one, do zoom 6. Zoom 6 is standard zoom, and it's your negative 10, 10, 1. Okay, I don't know if you recognize that, but that's basically the top half of a circle. Notice it doesn't seem to connect down to the x-axis. This is where these graphing calculators can mislead you. One, two, three, four, up to negative 4. 1, 2, 3, 4. Yeah, can you see how your 4 tick marks over in each direction?
Mm-hmm.
Okay. So, and if you look, your 4 tick marks up. Your 4 tick, I know it looks really flat. That's just the pixels that get lit, but your 1, 2, 3, 4 tick marks up on the y-axis. Those things should connect. It just doesn't show you that. And the reason I know they connect, and they connect with closed circles, 4 is legal. X equals 4. I get the square root of 16 minus 4 squared. 4 squared is 16. This is the square root of 0, which is 0. So it should come all, and 0 is the x-axis. It should come all the way down to 0 and all the way over here to 0. Just isn't showing you that. Can you then tell what your domain is? Well, this x min is negative 4. X max is 4. You'd be running between negative 4 and 4. You see why you can't use anything bigger than 4?
Mm-hmm.
Your number squared would become bigger than 16. That means 16 minus that would be negative. You can't do the square root of a negative. So these are the only legal x values into this from the graph. You see your range? Again, y min, y max. Your minimum y is 0 at the x-axis, and your maximum y is
4.
4. And again, with brackets. I can show you the algebra on it. The algebra, you'd have to solve 16 minus x squared greater than or equal to 0. You'd factor this, set up the number line, test each interval, and you'd find the interval between minus 4 and 4 only works. The other intervals does not. Any interest in seeing all that gibberish?
Not really.
Okay, no problem. Okay, well, that about finishes 2-3. At least that should at least get you started in on it. Do you want to see what they're asking you to do in 2-4?
Actually, I have to go get on another Zoom call.
No problem at all. I'll keep the recording going, and I'll work another couple problems from 2-4 if you want to look it back up. You feel free to.
You're gonna post this Zoom, right?
I am going to. Yes, I've been posting every Zoom.
Okay, good.
Yep.
Okay.
Okay,
Thank
well, I
you.
appreciate you showing up. Thank you.
Thank you.
Okay, just charge into section 2-4, page 224. And it's asking about net change versus average rate of change. Usually abbreviate this AROC. This is just nothing but you may be used to M, which is slope, which is your y2 minus y1 over your x2 minus x1. Net change is even simpler, is just your y2 minus y1. You may see it in the book f of b minus f of a. It's the top of the slope formula. So if I go to page 224, number 7, and they're giving me a graph. And it's kind of a red curve, so I'm on number 7. They've given me a dot over at 1 and up 3. And another dot at 4 and up 5. They're curving the curve kind of between these. So part A asks for net change. This is x, this is your x, this is 1 and 4. And your y's are at 3 and 5. Your net change then is 5 minus 3, which is 2. And you can see vertically, you have 2. Net change. Y2 minus Y1. In part B, your average rate of change is equal to your slope. So that would be your 5 minus 3 over your 4 minus 1. Meaning your coordinate here is 4 and 5. Your coordinate here is 1 and 3. So this is your y2 minus y1, which is exactly what net change is. In fact, I didn't even have to work it out again. I could have just used that answer. x2 minus x1, 2 over 3, 2/3. You know, I've risen 2 for a run of 3. So my slope is the division of the 2 over the 3. Rise over the run. All right, it's a little tougher down at 11 to 21. And I think that's all I asked about, or no, actually 7. Actually, I asked for 7 through 23 over to here. Okay. Here's a formula. Let's try one like 15. Page 224, 2.4. H of t, 2t squared minus t, t equals 3 equals 6. Don't really need the graph. Net change, part A asks for net change, which is basically y2 minus y1. These are your y's. Well, these are like your x's. The t's here are like your x's. So to get this y2, I've got to take y2 would correspond to this and y1 would correspond to this. I find y2 by plugging t equals 6 into the formula. So y2 would go basically h of 6, which would go 2 times 6 squared, subtract 6. 36 times 2 is 72, minus 6 should be 66. Same game with the y1 should be h of 3. 2 times 3 squared minus 3, which should be 18 minus 3, which should be 15. So my net change, 66 minus 15 should be 51. My average rate of change, minus y1 over x2 minus x1. I don't want to repeat all of this. This is basically my net change over 6 minus 3, which means I get 51 over 3. I think you'll find that divides out to 17. Maybe I should double check that. I believe 51. 17, yeah. So basically net change is half of an average rate of change problem. Net change is the top half of an average rate of change problem or slope problem. Maybe I'll try one more. Finish off this. Page 224. How about problem 23? They use letters. 23. F of t is 2 over t. T equals a to t equals a plus h. This is like your x1, this is like your x2. y2, plug in t equals a plus h. So for y2, you get 2 over a plus h. For y1, you get 2 over a. You're plugging in a. Net change, y2 minus y1, 2 over a plus h minus 2 over a. average rate of change, y2 minus y1 over x2 minus x1, 2 over a plus h minus 2 over a divided by a plus h minus a. See, I'm subtracting the two x values. That would give you 2 over a plus h minus 2 over a divided by h. That's probably not going to be the answer in the back of the book. So we should simplify. Get a common denominator on top. That would be 2a minus 2 times a plus h over a plus h times a. In other words, your common denominator puts together the a times a plus h. So your 2a goes up this way and your a plus h goes that way. Put them together on bottom, I got to put them up to the top. Please don't make me freeze in the middle of this. Okay, maybe, okay. So that would give me 2a minus 2a minus 2h. Oh, dividing by h. Over a times a plus h divided by h. That would give me negative 2a's cancel, negative 2h over a times a plus h divided by h over 1. That would give me negative 2h over a times a plus h. Take the top times the flip over the bottom, flip of the bottom. H's cancel. I wind up with negative 2 over a times a plus h. That's my average rate of change. A lot of algebra to get to that. Let's see how close I got. Might look like an idiot here. 2-4, problem 23. Problem 23. Two, 4, problem 23. Okay. I didn't simplify A, but B, negative 2 over A. Let's see it. Oops, look at the wrong. Okay. 23. Negative 2, there it is. Over a plus h. I didn't simplify part A. I just left it alone, separate. You can see how much work it is to simplify it. All right, well, that should give you pretty good intro to 2-3 and 2-4 for this week. We'll repeat this again at 9 p.m. tonight, and we'll end the meeting. Thank you.